Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet questions number 61 through 70. Milk has a pH of 6.7, which is slightly acidic. Cheesemakers add a culture to milk to lower the pH, making it more acidic and turning it into cheese. A manufacturer is experimenting with a new culture that claims to produce a pH of 5.2, which is perfect for cheddar cheese. A set of 50 test batches resulted in a pH of 5.11. A one sample t test was conducted to investigate whether there's evidence that the pH is different from 5.2. The test resulted in a p of 0.018. Which of the following is correct interpretation of the p value? Well, the p value is the probability of getting a test statistic as extreme or more extreme given that the null is true. All right. So in this case, we're looking at the probability of observing a sample mean of 5.11 or less um, if the mean is true. Well, that's true, sort of, because they said they're testing it. Um, they gave me a different HA. Our HO was the mu is 5.2. The HA, the mu was um, whether the evidence is different. So this means not equal to 5.2, which makes this a two-tail test. So that means it could be less than 5.2 or greater than 5.2. Well, that means if since I got 5.11, that's uh, zero point 0.8 away from it. So we have to be below and above. We have to look not just below, not just above, below it at 5.11, because 5.2 minus the 5.11 gives me 0.09. Well, we know that that's the lower end. So on the higher end, we have 5.2 plus 0.09, which is 5.29. And the reason we have to do that is because it's two-tailed. So the probability of observing a sample mean of 5.11 or less or 5.29 or more is this if the true mean is 5.2. So given that the null is 5.2, there's a 0.018 probability that we'd have this or less or this or more. All right. So our answer choice for 61 is E because it's a two-sided test. So we have to consider both sides on the p-value. When leaving for school on an overcast morning, you make a judgment on the null hypothesis. The weather will remain dry. What would be the results for type 1 and type 2 error? Okay, so the null is dry. The alternative is rain. All right, type 1, I reject this and I believe that it's going to rain. Well, if I believe it's going to rain, I'm going to bring an umbrella with me, but it's an error. So I'm bringing an umbrella when I don't need it. All right. So type 1, needlessly carrying an umbrella. That sounds pretty good. Type 2, I believe it's going to be dry, so I don't bring an umbrella, but I'm wrong. I made an error, so it's going to rain. All right. So I don't bring an umbrella and it's going to rain. So type 2, didn't bring an umbrella. It rained. I got wet. I got drenched. What is the probability of a type 1 error when a hypothesis test is being conducted at the 5% level of significance? Alpha, or the level of significance, is the probability of a type 1 error. So it's just a definition. So, hey, I don't have to do any figure. Oh, this says what's the probability of a type 2 error? Type 2 error, I can only calculate if I can go, well, power equals 1 minus beta, and beta is type 2. Well, I can calculate type 2 if I know power. I don't. These two are related. As alpha goes up, beta goes down, but I can't um, calculate that. All right. So there's insufficient information. I don't have enough to be able to calculate it. Can't calculate it directly. Which of the following is a true statement? The probability of a type 2 error does not depend on the probability of a type 1 error. No, it's just what I said above. They are related. As one goes up, the other goes down. So that's false. All right. So that takes care of that one. That takes care of A is wrong. In conducting a hypothesis test, it's possible to simultaneously make both. No, you can't, because this is reject and this is fail to reject. If I reject it, I can't make this. If I fail to reject, I can't make this. So I can only do one, and I may not do either. A type 2 error result in one correctly assumes that the data are normally distributed. That has nothing to do with a type 1 or 2 error. Type 1 error is rejecting when I should not have. Type 2 is failing to reject when I should have. So those two are not related to normality. Type 1 and type 2 errors are caused by mistakes, however small, by the person conducting the test. No, that's not true. They happen by random chance alone. So that's not it. A type 1 error is a conditional probability. Guess what? Type 2 error is conditional. Type 1 is conditional. P-value is conditional. All right. And power is conditional. So type 1, type 2, power, and p-value are all conditional probabilities. So best answer for 64 is E. 65. An assembly line is supposed to turn out bowling balls with a diameter of 8.55. So HO, mu equals 8.55. Alternative. Each day, simple random sample of 5 balls are pulled and measured. If the mean diameter is under 8.35 or over 8.75, the machine is stopped. So it's stopped if it's different than 8.55. All right. And it's only stopped if it's less than 8.35 or more than 8.75. So the quality control manager may be viewed as a hypothesis, and there it is. What would be a type 2 error? Type 2 is fail to reject. Type 2 is fail to reject. Well, if I fail to reject, I believe it's this, but that's false. So I believe I'm making 8.55 balls, but I'm not. They're the wrong size. So I'm producing balls that are the wrong size. So continue production of the wrong size bowling ball because I failed to reject it. I failed to reject it, so I'm still producing, and I'm producing the wrong size ball. Given an experiment, mu equals 25 and mu is greater than 25, and a possible true population of 26, which of the following which of the following increase with the increase in the sample size? All right. So if I increase sample size, I decrease power, I decrease type 2 error. Please keep in mind, increase in alpha or type 1 goes down. Beta or type 2 goes down. Power goes up. All right. So in this case, 66 is C, which is the power of the test. Power goes up. Which of the following statements is incorrect? The significance level of a test is the probability of a type 2 error. The significance level, it says which of the following is incorrect. And significance level of the test is the probability of a type 1 error. So this for 67, A is false. So that's my answer. All right. Which of the following, for 68, which of the following is incorrect? The power of the test concerns its ability to detect a true alternative hypothesis. That's close. Let's see if there's anything better, because really it's the power of the test is correctly rejecting a false. So we really don't talk about whether it's true here. So I don't really like this one, but we'll consider it as a possibility. The significance um, um, level of test is the probability of rejecting a true null. All right. Significance level, type, that's a type significance level, or alpha is the measure of a type one, which is rejecting a true null. So this is actually true. So that one's true, and we're looking for incorrect. Don't forget that. The probability of a type one error plus the probability of a type two error always equals one. That's 100% false. They don't add up to one. Um, Power plus type 2 add up to 1, but not type 1. I mean, power plus type 2 add up to 1 whole, but these two do not add up to 1. So this is false. This is my best answer. All right. 69. P equals 0.6, probability of greater than, and so this is my ho. My ha is that the proportion is greater than 0.6, and the alternative is P equals 0.7. All right. The power is zero point 0.8. Which of the following is a valid conclusion? So if P is zero point 0.7, the probability of failing to reject is 0.2. Well, power, first off, it really is P is 0.7. This is the truth. Right here, this is the truth. So if that's the case, I should be rejecting. Well, it says the probability that I will correctly reject is 0.2. And remember, power equals 1 minus beta, or 1 minus type 2. So 0.8 equals 1 minus beta. And when I solve for that, I end up getting beta equals 0.2. So the probability of committing a type 2 error or failing to reject is 0.2. Because remember, failing to reject is failing to reject a false null. So there we go, right? If this is true, so given that this is true, the probability of committing a type 2 error is 0.2 because the power is 0.8, or 1 minus beta. All right. Number 70. The company will market a new hybrid luxury car only if they can sell it for more than 50,000. All right. So there's a claim. They do a random sample of 50 potential customers and a hypothesis. And if they have greater than 50,000, they'll produce the car. What would be the consequences of a type 1? A type 1 says, I reject this and I'm believing this. So I'm going to basically go, hey, I'm going to now produce a car. So I'm going to produce the car because I believe it's going to be more than 50,000. But this was actually true. All right. So I'm producing a car that is not profitable because it's not over the 50,000. It's actually this, it's less. Produce a non-profitable car. All right, that's type 1. We also have that down here, produce a non-profitable car. So that gets rid of B, C, and D. Type 2 error. Type 2 error. I believe this. This is what I believe. So I don't do this, but this was the actual true and this is false. In this case, type 2 is I failed to produce a profitable car. All right. So type 2 failed to produce a profitable car. So the answer choice is 70 is A. All right. I appreciate you watching and I hope to see you on the next one. Thank you.